So today we're going to learn about non-real answers. And non-real answers do happen in real life, even though they're imaginary. They do happen in real life. I know that if you go into being an electrician, you will have to deal with circuits. And those circuits, something I shouldn't even be recording that I'm saying this, but I don't know a lot about it. But I know that they do involve imaginary numbers. So if you are going to be an electrician, which does not require a college education, you still need to know about imaginary numbers, even though they're not real. So an imaginary number was created to do things like make circuits, and we use them to manipulate higher level math. They're not there, but we use them. To get an imaginary number, we take the square root of -1. And we know to do the square root, you have to have the exact same number multiplied by itself. But to get a negative number, it would have to be 1 positive and 1 negative. Those aren't the same number. So they created this imaginary number, and we call it I. It's a lowercase cursive I. It is not a capital I. It is lowercase cursive I. That is an imaginary number. It is the square root of -1. And if I take I and I multiply it by itself, definition of square root, if I take I times I, it would have to be what's under the square root, -1. So I times I, which is I squared, by the way, is -1. And that's why we can take the square root of -1 and say it's I. So where we would use that, on that last example we were just talking about, when you told me, oh, there's no real answer because you can't square root -25, now we can. There is no real answer, there's imaginary answers. So I have, on that last example we were just talking about, x equals positive or negative square root -25. And what I'm going to do is, I'm going to make a factor tree with -25. I'm going to factor out the square root that I know, 25, and the square root of -1. And you're going to tell me, what is the square root of 25? The plus minus comes down. The square root of 25 is 5. And what's the square root of -1 we just learned? I. So if I needed an answer, if it wasn't a question if it's real or not real, if I needed an answer, it would be positive or minus 5i. Imaginary. Oh, I guess we already did A. Didn't realize that was the same question. So should have picked a different number. So anyway, review. We separate it to 25 and -1. 25 becomes 5. Square root of -1 is I. And that would be simplifying square root of -25. So the middle one. Can I take the square root of -72? No, so I'm going to separate out square root of 72 and square root of -1. Thank you. Now can I take the square root of 72? It's not a perfect square, is it? So you have to simplify when they're not perfect squares, but they can be simplified. You have to simplify them. And I believe we did this the other day, but we're doing it more. So you have to say, what two numbers can I multiply together? Give me 72. One of them has to be a perfect square. And one of them should be the biggest perfect square that divides evenly into 72. Do you know what it is? 36 and 2. So we break 72 down to 36 and 2. Square root of 36 is square root of 2. So now I have the square root of 36, which is 6. The square root of 2 is not something I can find the answer to, so it's just square root of 2. And the square root of -1 is I. When you rearrange that in the correct order, the radical goes last. It goes the order of 6 and then the imaginary part, and then the radical. And that's so we don't think the I is underneath the square root. So we put it in front. So C, we've got -5 multiplied by square root -9. Can I take the square root of -9? No. So I'm going to separate the square root of -9 to the square root of what and the square root of what? Nine and square root of -1. And then that -5 out there is being what operation with the square root? Multiply. So I'm still multiplying it by whatever this becomes. It's still there. And then we say, well, what's the square root of 9? What times itself is 9? Great. We multiply that by -5, and the square root of -1 is I. So we have the answer -15I. Okay, there are 4 you try. So you try. I walked around, most people has 1 done, so I put the answer for number 1 up. With number 2, some of you broke it apart in different orders, but I would start with 12 and -1. That's what I would start with, but it doesn't really matter what order you go in necessarily. And then from there, the 12 breaks down to 4 and 3. So we have square root of 4, which is 2. Square root of 3 doesn't have anything. That simplifies. And square root of -1 is I. We put it in the correct order. 2I square root 3. Number 3, there's a negative sign outside, and there's a -36 underneath. So underneath, we get radical 36 and radical -1. That negative sign out front stays there, and it's being multiplied. Then I simplify my square root of 36, and I get -6, and then my square root of -1 is I. And then the last one has a 2 out front, and we're going to break down the square root 54 to square root something and square root something else. What makes 54? Oh, 54 and -1. That first. Then I'm going to break down 54. What makes 54? 9 and 6, yep. That 2 is still out front. So 9 becomes 3. So when I go to combine it all together, I have that 2 out front, and then the 9 became 3. What operation is in between this 2 and the 3? It's a multiply. So we have +6 oops, I forgot my I, and then square root 6. Okay. All right, one last section, real fast, one last section. I'm not going to do this equality yet. We'll do that on Friday. I'm going to do sum and difference of complex numbers. So we have imaginary numbers. They, together with the real numbers, they are called complex. That's what they're called. They're called complex. And they're in the form of like A plus BI. A would be like the real portion, and BI would be the imaginary. So if I gave you the number, if I said 5i, would that be like the A, or would that be like the BI? The BI, that would be imaginary. If I gave you the number 6, would that be like the A, or would that be like the BI? The A. And if I gave you 6 plus 5i, that would be in the form of a complex number, where you have both the real and the imaginary portion together. Down here, we're going to add or subtract complex numbers. And this add or subtract complex numbers is the same way that you add or subtract anything in math. Like if I wanted to add 3x plus 2x plus 7, what would I have to think about to add anything in math? Can I add that together? What can I add together with 3x plus 2x plus 7? What adds together? Chava? 3x plus 2x gives me what? Okay. And what do I do with them? 7. Just plus 7. Why can't I add 5x and 7 together? Because they are not like terms. In order to add stuff together, we have to have what? Like terms. So when I talk about adding imaginary numbers, and I talk about the real part and the imaginary part, real and imaginary are not like terms. We do it the same way we do stuff with x's. Here I've got 8 minus I, and I'm adding 5 plus 4i. What like terms can I add together? What adds? The 5 and the 8, which gives me 13. And then I also heard the 4i and the minus I, which gives me 3i, which is positive, so plus 3i. You're just combining like terms. So we got to do B, and B is subtracting. So we can't just let the parentheses just disappear. What do we have to do with that negative sign in the middle? You have to subtract the 3 and subtract the negative 6i. So we have 7 minus 6i minus 3 plus 6i. Remember, you want to distribute that negative sign in, and you're basically doing the opposite operation. What like terms can I combine? 7 and minus 3, which is 4. And then minus 6i and positive 6i is 0i. So you could either write, or you could write just 4. Either of those would be fine. Okay, and then the last one, we have a parenthesis, and in front of the parenthesis is a negative sign. So that means I have to subtract the 2 and subtract the 7i. So I have 13 minus 2 minus 7i, and then plus 5i is not part of the parenthesis, so I just bring it down, plus 5i. So I got rid of my parentheses. So how many like terms that I could add together? Always add like terms. What's like? 13 and minus 2, 11. Negative 7i plus 5i. and we haven't. So that's like half of the lesson for Friday. On Friday, we will have, we didn't do the practice ones, but on Friday, we will have an assignment online. If you get done with this worksheet early and you wanted to start it early, I would not suggest doing all of it, because I haven't showed you everything, but you could at least start some of it if you wanted to. But that is not due till Monday. You have the rest of the class